Welcome to this advanced demo series where you're going to get some exposure in implementing a full code pipeline to deploy an application within AWS. Now this advanced demo is going to use CodeCommit, CodeBuild, CodeDeploy and CodePipeline, and it's going to be an extension of the theory that you've already learned in a previous theory lesson. Now you don't need to deploy any infrastructure at the start of this demo series. All I'll want you to do is to make sure that you're logged in to an AWS account using an identity with administrator permissions. If you're taking this video as part of my courses, then you'll need to be logged in to the general AWS account using the IAM-admin user. But any administrator user of a normal AWS account will suffice. As always, make sure you have the Northern Virginia region selected. Now, attached to each lesson in this series are text-based instructions which guide you through that particular stage, as well as any other assets that you'll need as you move through the activities which you'll need to implement. I've also gone ahead and included an architecture diagram which will give you an overview of everything that you'll be doing in each individual stage. Now at a high level, this is what you're going to be implementing. First, you're going to be using CodeCommit to create a source code repository. You're going to configure the security and clone that repository down to your local machine. Once you've done that, you'll be uploading some application code which I've provided attached to the text-based instructions. And for anyone who's done any of my previous courses, this should look familiar. It's a previous application that we've done during the container part of the course. So this application is a simple web page with some cat images, and we're going to use it to create a container, and this container will be deployed to ECS. So during each stage of this demo series, you're going to enhance this architecture, and by the end you'll have a full deployment pipeline which will build and deploy a container every time you commit new code to this repository. Now in stage 1 of this mini project, you're going to implement this architecture. So you're going to be creating and configuring a CodeCommit repository, giving yourself access to that repository, cloning the repository down to your local machine, adding some files, and pushing those files back up to the repository. Now as always, there are a full set of text-based instructions attached to this lesson. The first thing that you'll need to do though is to move across to your terminal. Now this part is important because the steps that you need to perform vary massively depending on whether you're using either Linux or Mac OS or Windows. Now Linux and Mac OS use roughly the same steps, whereas Windows is completely different. And in addition to the full text instructions, I've included links to each of these instructions attached to this lesson. So because I'm using Mac OS, I'm going to follow those instructions, and the first thing that I'm going to do is to move into the .ssh folder. This is the folder where all of the SSH keys and configuration is stored on my local machine. Next, I'm going to go ahead and generate an SSH key pair. It's going to be an RSA key type, and it's going to be 4096 bits. And so to do that, I'm going to run this command. So go ahead and use that command and press enter. You'll need to enter a name for the key pair, so go ahead and use CodeCommit and then press enter. We won't be using a passphrase, so press enter and then confirm that again. And that will save out the key pair into the current folder. So that's the .ssh folder in my case. I've got to clear the screen to make it easier to see, and the next step is that we need to get the public part of this key pair because that's what we need to upload to AWS. To get that, I'm going to run this command, so cat and then tilde/.ssh/codecommit.pub. Again, it will be slightly different depending on your operating system, but what we'll need to do is copy this entire public part of this key into our clipboard. So copy that into your clipboard, and then you can go ahead and move back to the AWS console. At the AWS console, go ahead and type IAM into the search box at the top, and then click to move to the IAM console, because we're going to upload this public key into our IAM identity. So click on Users. You should be logged in as the IAM admin user. So go ahead and click the IAM admin user. Then click on Security Credentials and scroll down, and we're looking for SSH keys for AWS CodeCommit. So this is how you authenticate with CodeCommit when interacting with repositories. You use an SSH key pair. You can also use HTTPS credentials, but I prefer to use SSH keys. So go ahead and click on the button to upload the SSH public key and paste the contents of your clipboard into this box. Then once you've done that, go ahead and click on the button to upload that SSH public key. Now it's going to show you the SSH key ID for the public key that you've just uploaded, and we're going to need that in the next step, so just make sure that you leave this screen open and then move back to your terminal. Now there's a configuration file in this folder called config, and we need to edit that configuration file. So we do that using this command. So we're editing using the nano text editor, and we're editing the SSH config file. Now it should look something like this. Don't be overly concerned if it looks different. What we need to do is add something to the top of this file. So just press enter and then move the cursor to the top of the file. Now inside the text-based instructions for this stage is a code snippet that you'll need to copy into your clipboard and paste into this file. It should look something like this, so you should have host and then git-codecommit.star.amazonaws.com. It should point at the identity file that you just created, so the key that's called CodeCommit inside this folder. Again, if you're using Windows or Linux, this might look slightly different. The key part that you need to worry about is that you need to delete this placeholder all the way to the space after user, so leave the space, and then move back to the AWS console and copy the SSH key ID into your clipboard. Now make sure that you don't copy the key ID for your access keys. We need to make sure that this is the SSH keys for AWS CodeCommit. So copy that into your clipboard, move back to your terminal and paste in that key ID. Now that's going to ensure that whenever we attempt to authenticate to CodeCommit, this is the SSH key that we use. So go ahead and save that file and then exit out of your editor. Now I'm using macOS, so I just need to make sure that the permissions on this file are appropriate. So I'm going to use a chmod space 600 space and then the path to this config file. Again, if you're using Windows or Linux, these steps may vary. I'll clear the screen again to keep it easy to see, and then finally we need to test that we can authenticate through to CodeCommit using this SSH key that we've just created. And to do that, we're going to use this command. This is a simple connection command which attempts to connect to git-code-east-1.amazonaws.com. So go ahead and run that command. What you should see is you have successfully authenticated over SSH. Don't worry about any of the other text, even if it looks like an error. The only thing that we care about is that you have successfully authenticated over SSH. So that's the authentication part of this process configured. We can now interact with CodeCommit from our command line. So we can use the git command to push or pull any code into or out of any repositories within CodeCommit. So let's go ahead and move back to our AWS console, and the next step is that we need to create the CodeCommit repository. So to do that, click in the search box at the top and just type CodeCommit, and then click to move to the CodeCommit console. Once you're at the CodeCommit console, just make sure that you're inside CodeCommit, so click on repositories, and at this point you probably shouldn't have any repositories created within CodeCommit, so we're going to create one. So go ahead and click on create repository, go ahead and enter a repository name. So I suggest you use CatPipeline-CodeCommit, and then if this were production usage, you'd probably have many of these, so you need to make sure that they're unique and easily distinguishable. So often you might want to put a unique ID or a project code at the end, and you could just use another hyphen and then use a particular ID for project code or anything that you want. I'm going to go ahead and use CatPipeline-CodeCommit, and then I'm going to add 1337 onto the end, just so that I know what repository this is. Go ahead and name your repository and then click on Create. Now once you've created that repository, you'll see there's a dialog which shows you the connection steps to interact with this repository. Now as I mentioned before, you can use HTTPS to interact with the repository, but I prefer SSH. So go ahead and click on SSH, And this is going to give you the connection instructions for all of the 3 popular operating systems supported by this course, so macOS, Windows or Linux. In my case, I'm using macOS, so I'm going to expand that. It's going to give you the steps required to interact with this repository, and you'll notice those are the same steps that we've already taken. So registering a public key, editing the local SSH configuration, adjusting the permissions on this config file, and then the last step is to clone down the repository using this command. So go ahead and copy that into your clipboard and then move back to your terminal. I'm going to clear the screen to keep things easy to see. And then I'm going to move to my home folder by typing CD and pressing enter. Now I always recommend with my courses to have a location where all of your repositories are kept. In my case, I have a folder called Repos where all of my repositories are, and then within there I have another folder where all of my course-based repositories are stored. So I'm going to move into that folder. You should get into the habit of creating a similar folder structure for all of your repositories, but whatever structure you use, you need to move into the folder where you want the repository stored, because next we're going to clone the repository down to our local machine. So I'm going to clear the screen to keep things easy to see, and then we'll need to paste in the command that we've just copied into our clipboard and press enter to clone this repository down to our local machine. So it's going to clone the repository down into a folder with the same name as the repository name. You'll see a warning saying that you appear to have cloned an empty repository, and that's okay because the repository is empty. We've just created it and it currently contains no source code, and that's okay. Now the next step is that we need to add some code into this repository. Now attached to the instructions for this lesson is a link to download a file called container.zip, and this is the source code for a simple containerized application which you may have used from my other courses. So go ahead and click this link to download it to your local machine. Once you've downloaded this container.zip file, go ahead and extract it, and this is what this folder should look like. You might recognize this if you've done my other courses. This is from a lesson where you create a Docker image and then you use that to run a Docker container both on EC2 and within ECS Fargate. What we're going to do in this demo series is automate the process of building and deploying this Docker image. So all of these files, you need to go ahead and copy those, and you need to copy them into the repository that you've just cloned down to your local machine. So in my case, this is the repository CatPipeline-CodeCommit-1337. I'm going to go ahead and paste in all of those files. And there we go, we've got 6 cat images, a Docker file, and then an index.html. And once we've done that, we can go ahead and move back to our terminal, and we're going to add these files locally into our staging area, commit them, and then push them into the remote repository. We're going to move into the repository folder that we've just cloned down, and then we're going to run this command, so git space add space hyphen big A space dot, and that's going to add all of these files in the current directory signified by a period. So press enter, and that will add all of those files. Then we need to commit these files, so git space commit space hyphen M for message, and then speech marks, and then we'll just type a brief comment, container of cats, and then another speech mark, and press enter. And that commits all of these files. And lastly, we need to use a git space push to push those files up to CodeCommit. That'll take a few moments. Once it has finished, you'll see that it's created a new branch. Once that's done, we can move back to the AWS console. Once we're back at the console, if we click on code, we'll be able to see that now inside this repository are all of those files which we just pushed into this repository. So that's everything that you need to do in stage 1 of this demo series. You've successfully configured security so that you can interact with any repositories within CodeCommit. You've created a repository, you've cloned it down, you've added some files, and then you've done your first commit and pushed that back up to this CodeCommit repository. So now we have files within this repository, and we have a single branch that's inside this repository. In part 2, you're going to get the experience of working with CodeBuild, and CodeBuild is going to automate the process of creating a Docker image from the files in this repository. Welcome to stage 2 of this mini project where we're going to implement this architecture. You're going to set up ECR, so the Elastic Container Registry, and this is going to be used to store the output of the CodeBuild process. So this is going to be fully automatically built Docker images. In addition to that, you're going to configure the CodeBuild process itself. This is going to take any files and configuration located within the CodeCommit repo that you previously set up. It's going to take all of those files and it's going to build a Docker image which is going to be stored in ECR. So this is going to be a really valuable part of this demo series where you're going to get some great experience. So to start with, what we need to do is move across to the ECR console. So click in this search box and type ECR, and then it's probably better to open that in a new tab. So Elastic Container Registry, and then move to that tab. And once there, I want to draw your attention to a number of things. So within ECR, you can have public registries, and this allows anyone to have read-only access to repositories containing Docker images. And in addition, you can configure read and write access using normal AWS security. So we're going to go ahead and create a repository. So click on Create Repository. We're going to set it as a private repository, and you'll note that the repository name is prefixed by your account number, and then .dkr, and then .ecr, and then the region, and then AmazonAWS.com. And so the name that we enter here only has to be unique within your account in this region. So go ahead and enter the same name that I do. We're going to use CodePipeline. So this is going to be the name of this repository. Once you've entered that, scroll down, and we won't be setting any of these options. We won't be scanning these images on push, and we won't, for this demo series, be using KMS encryption. So just go ahead and create the repository. Now we're going to leave this tab open because we're going to need some of this information at a later point. Next, we need to create the CodeBuild project itself. So click in the search box, type CodeBuild, and open that in a new tab. We're going to need to move to that tab, so do that. You shouldn't see any build projects created at the moment, but we're going to go ahead and create one. So create a build project. Now this build project is going to automatically build a Docker image from any files contained within our CodeCommit repo. So we need to configure the source, we need to configure some elements of our environment, as well as telling CodeBuild exactly what to do as part of the build. And that process is configured within a file called buildspec.yaml, and we're also going to configure that file. Now the first thing we need to do is to name this project, so put catpipeline-build. Once we've done that, we need to point this build project at our source, and in this particular case it's going to be the CodeCommit repo that were created in the previous stage of the demo series. So for source provider, make sure it says AWS CodeCommit. Click in the repository search box and select the repository you created in the previous stage of the demo. Once you've selected that, you'll see some CodeCommit specific configuration. We're going to use branch as a reference type. Click in the branch drop-down and select the branch that you've already created in the previous stage. Once we've done that, we'll move to the next section, which is environment, and this configures the environment that's used to build our project. So this is delivered as a service. You only pay for the resources used to build your projects. And it's here where you configure exactly what that environment looks like. So for environment image, we're going to select a managed image. So use an image managed by AWS CodeBuild. The alternative is to specify a custom Docker image to use to build this project. But we're not going to do that. We're going to use a managed image. We need to select the operating system to use, so click in the drop-down and select Amazon Linux 2. Click in the runtime drop-down and select Standard. Click in the image drop-down and go ahead and select AWS CodeBuild Amazon Linux 2 -x86 _64 -standard, and then just pick the largest number. You may have a later one when you're watching this video. Just make sure that it's Amazon Linux, make sure it's x86 64, make sure it's standard, and just pick the highest number that you see listed. Under image version, select always use the latest image for this runtime version. Under environment type, make sure it's set to Linux. then check this privileged box because we are using this to build Docker images, and it suggests that we need to use this in order to get the required permissions to do that. So we need elevated permissions. So check this box. Now at this point, CodeBuild wants us to specify the service role that's used by this build project to interact with AWS services. It can either create a new service role on our behalf, or you can use an existing service role. Now we're going to create a new service role, and we'll use the default name for this role. So CodeBuild-catpipeline-build-service-role. So everything should be set to that automatically. If not, just make sure you pick new service role and use this for the role name. Now we also need to expand this additional configuration because we need to specify some additional configuration details. So expand this. You're able to configure timeouts, you can specify certificate information, you can configure VPC that your CodeBuild project can access, you can control the memory and compute allocated to the build process. We'll be leaving all of these as default. What we're going to be doing though is adding some environment variables, and these will be used during our build process. Now the environment variables to use are within the text-based instructions that are attached to this lesson, so you can copy and paste these out of the instructions. So first, for environment name, we need AWS_default_region. Click add environment variable 3 more times so that we have a total of 4. Next, for name, AWS_account_ID. Next, image_tag. And then finally, image_repo_name. Now we'll need to specify values for each of these environment variables. Under default region, as normal, US-East-1. Under AWS account ID, you need to put in your account ID. So if you click on this drop down and then just click on this copy symbol next to your account ID, it will copy the account ID without hyphens, and that's the format that we need. So paste that in. Now you can customize exactly what happens during a build process, and as part of this we're going to need to tag our Docker images. Now we're going to enhance this in the next stage of the demo series, but for now I want to set it so that every single time we create a Docker image, it's tagged with latest. So go ahead and enter that under image tag. You'll see how this is used momentarily. These don't directly apply to the build process, they're set as environment variables. And what you'll see is when we look at the buildspec.yaml file, you can see how we utilize these variables. Now lastly, we need the repository name. This is going to be the repository where the Docker images are stored into, and this is used by the buildspec.yaml file to control where the final destination image is stored. Now we're going to use the name of the repository that we've just created, so go back to the ECR tab, and you need the repository name. You don't need this longer URI, so in our case, it's simply CatPipeline. So copy that into your clipboard, and paste that into this box. So they're the environment variables that we need for our build process. We only need those 4, so now we can continue to the build spec section. Now this is important, so when you're using CodeBuild, it's going to be performing a number of steps within the build environment. And exactly what these steps are is controlled by the build spec file. So this is a YAML formatted file, and you need to have this accessible to CodeBuild. Now you can either insert these build commands directly into the build project, or you can specify the location of a build spec file. And normally this file is located in the same place as your application code, in this case on our CodeCommit repository. And that's what we're going to do. We're going to put the build spec file into the CodeCommit repository, and we'll step through exactly how that works in a few moments. Now the build spec name is optional. CodeBuild by default will look for a file named buildspec.yaml, so YML, that's located within the root directory of the repository. Now, if you had this file at the root level but it's called something else, you need to specify that name here. If you don't have it at the root level, you need to specify that name here. You can also specify it even if you're using the default, so you could put buildspec.yaml in this box anyway, but it is entirely optional if you are calling it buildspec.yml and it is in the root of the repository. But I'm going to explicitly state it. I always find it safer. So go ahead and put buildspec.yml into this box. Now, artifacts are the name given to the outputs of a build stage within the code suite of products. So CodeBuild will normally output some build artifacts, and you may take those build artifacts and input them into CodeDeploy to be deployed into your infrastructure. Now, right now, we're not going to be generating any artifacts. We're only going to be outputting a Docker image, and this is set outside of this process. So for now, we won't be setting any artifacts, but we will be coming back to this at a later stage to adjust it, and I'll explain why in the next stage of this demo series. For now, though, we won't be needing to set any artifacts. Scroll down and you're able to set the log output location for this build project. You can use CloudWatch logs or S3. Now, in our case, we'll use CloudWatch logs because it's just simpler. So in the group name, just put A4L-CodeBuild. And then for the stream name, go ahead and enter CatPipeline. And this will just make sure that we do have a record of any status messages or errors as part of the build process. That's everything that we need to set for this build process. So go ahead and scroll right down to the bottom and create that build project. Now, we're not going to start a build yet because there are a number of other steps that we need to do. Firstly, this build project is going to have to interact with other AWS services. Namely, it's going to have to store the resultant Docker image into ECR. And so we need to make sure that it has the permissions that it requires. Now, I mentioned while setting up this build project that it uses a role to interact with other AWS services. And so what we need to do is adjust the permissions on that role to give it access to everything that it needs. So that's what we're going to go ahead and do. So we're going to go ahead and move to the IAM console. So click in this box and type IAM and then open that in a brand new tab. Once that's loaded, click on roles. Now, the list that you might see might differ slightly from mine. It depends on how far you are in the course. In my case, I've got roles that are created in other lessons of this course. What you're looking for is the role name of CodeBuild-CatPipeline-build-service-role. So this is the role that's going to be used by our CodeBuild project. So go ahead and click on this. And then we're going to need to add a policy to give it access to everything it needs. So to do that, click on Add Permissions, and we're going to create an inline policy. So go ahead and do that. We're going to edit the JSON directly, so click on JSON, delete the placeholder, and then in the text-based instructions attached to this lesson is a code snippet for the permissions that you need. So go ahead and copy that and then paste that into this box. Now, this will give it the permissions that it needs to interact with ECR, specifically the ability to put images into ECR, as well as upload layer parts. So all of these are required for CodeBuild to interact with ECR, and that's what we need. So click on Review Policy. For name, put CodeBuild-ECR, and then create that policy. So that's the permissions that CodeBuild requires. The next step is to configure exactly what CodeBuild will do to the files in our repository. And for that, we need to create a buildspec.yaml and add it to our CodeCommit repository. So that's the thing that we're going to do next. Okay, so I'm just going to switch across to my code editor, and this is the buildspec.yaml file that we're going to use to create a Docker image from our CodeCommit repository. Now, the text for this is included in the text-based instructions attached to this lesson. So what I want you to do is to copy it out of those instructions and paste it into your favorite code editor. Now, there should be the ability in your code editor to select it and convert tabs to spaces. The YAML file format doesn't allow tabs, only spaces, and so we need to make sure that when copying from something like GitHub, we remove all of the tabs and replace them with spaces. So I'm going to go ahead and do this in my editor. So I'm going to select it all and then go to the editor menu and then convert tabs to spaces. And any good code editor will have have this option, it will have the ability to change from tabs to spaces and vice versa. So make sure, just once again, because this will cause problems if you don't do this correctly, select all of this text and then convert tabs to spaces. Now a buildspec.yaml file is a formally defined file structure which configures exactly how CodeBuild works. Attached to this lesson, I've included a build specification reference for CodeBuild link, and this gives you a complete overview of exactly how this file is structured. Now for this demo series, our example is relatively simple because we're only creating a Docker image from the contents of a repository. CodeBuild is capable of performing complex build and test processes, and so the contents of this file defines exactly how CodeBuild operates. So this is the build spec YAML file that we're going to be using. So the pre-build component of this runs a command that gets a login password for ECR and then passes that through to Docker login. And this is how we get the permissions to store the resultant Docker image onto ECR. The build component of this file essentially outputs a number of diagnostic messages, and then it runs a docker build command which builds a Docker image from the Docker file specified as being in the current directory. So essentially we have the Docker file that contains the list of directives on how to build the Docker image, and by running docker build, pointing it at the local directory, the CodeBuild environment will take the CodeCommit repository and it will build our Docker image, which during the post-build section will be pushed into ECR. So that's how the whole thing works. We log in to ECR, we do a Docker build to create the actual Docker image, and then we push this up to ECR within the post-build section of this buildspec.yaml file. So what we need to do is we need to save this into our local copy of our repository. So the local copy of the CodePipeline repository that we created earlier, we need to save this in the top level of that repository. So I'm going to go ahead and do that now. So this is my repository folder, and I'm just going to go to Save As, and I'm going to call it buildspec.yml, and it's going to be saved at the top level of this repository. So I'm going to save that file. And now that I've saved that file, that contains all of the directives that CodeBuild needs to execute this build environment, build the Docker image, and push that Docker image into ECR. So now I need to add this buildspec.yaml file to a local commit and then push that into CodeCommit. So I'm going to move back to my terminal, and I'm currently within my local copy of this repository. I'm going to run a git space, add space, hyphen capital A, and then a period to add all files in this local folder. And then I'm going to create a commit, so git space, commit space, and I'll use the hyphen M to specify a message, and then a space, and then I'm going to add a comment. So I'm going to put add buildspec.yml. So this is just a message informing us what we're changing with this commit. So I'm going to commit that. And then the final step is to push these changes up to the remote repository, so the CodeCommit repository. So I'll run that git push, and that should be everything. So if I go back to the AWS console, just go to CodeCommit, refresh that. Now that we can see that we've got this buildspec.yaml file, and that means CodeBuild now knows what to do during the build phase, and it utilizes this Docker file, and it's this Docker file that will create a Docker image based on the contents of this folder. So essentially CodeBuild uses buildspec.yaml in order to know what to do, so it contains the directives, and those directives are to use Docker build to take this Docker file and use all of the other files in this repository to build a Docker image. Okay, so the next step is to actually run our CodeBuild project. You should already have the CodePipeline-build project open. If you don't, just go to Build Projects and select CodePipeline-build. Once you've got that open, just go ahead and start the build process. Now, while this is working, you're going to see an output of the build process in this logs dialog. It might take a couple of seconds to display at first, but what you're going to see is an output of the code build process. It's going to show an output based on what's in the buildspec.yaml file, and then once that file is parsed and used, then we're going to see outputs from the Docker build process. So you'll see each element of the build process within the build environment. If we scroll down, We can see that it's logging into Amazon ECR. Login succeeded. We can see that we're outputting these diagnostic messages that were part of the buildspec.yaml file, and that we're running the docker build command. Docker build is going to parse the Docker file and perform the steps that are detailed inside it. And so it starts by downloading the base image. Once it's downloaded that image, it starts performing each line of the Docker file in turn. Generally, that begins with some software installation. Then we can see the steps that we've defined. So we copy the index.html file into the Docker image. Then we copy the container and cat images into the Docker file. We define an entry point. We define an expose directive, and then the Docker container has been built. And then once the Docker container has been built, it's tagged and pushed up to ECR, and the process completes. So we can see that we've got an end-to-end process of creating a Docker image. Now, if we go back to ECR, we should still have a tab with that open, and go into the CodePipeline repository, we should now see that we have a Docker image inside this repository that's been tagged with latest. And if we click on that image, we can see all of the associated information. So that's been a simple example of using CodeBuild to automate the build process based on a CodeCommit repository. And the next thing that I want to do is to test this Docker image to make sure that it's functioning as we expect. Included in the instructions for this stage of the demo, so attached to this lesson is the instructions for this stage of the demo, and in those instructions is a link to a one-click deployment. Now, if you paste that link in, essentially everything is pre-populated. This is just going to provision an EC2 instance which has the Docker engine installed on it. So all we need to do is check this acknowledgement box under capabilities and then click on create stack. Now, this is going to take a few moments to complete, and we need this entire stack to be in create complete before we continue. So go ahead and pause the video, wait for your stack to change into create complete, and then we're good to continue. Okay, so now the stack is in a create complete state. So what we need to do now is to click on the resources tab and locate public EC2. Then click to move to the EC2 console, and this is the EC2 instance that's been launched, which has the Docker engine installed. So select this instance, right click and go to connect. We're going to use EC2 instance connect, so leave this selected and then go ahead and click on connect. Now, attached to this instance is an instance role with permissions to access ECR, so we can interact with the container registry by using the permissions that this instance role allows. And that's important to understand because we're going to use these role permissions to interact with ECR and get access to our Docker image. Now, the first thing I want you to do is to run a docker space ps and press enter just to make sure that the Docker engine is installed and working correctly. And if you get this empty list, then that means everything's okay. Now, the next command we're going to use is the AWS ECR get login password command. So that's this one. And what this is going to do is it's going to output authentication information which can be used by the Docker login command. So I'll just demonstrate what I mean by this. So if I press enter, this is going to output a long string which can be used by the Docker login command to get access to our Docker image on ECR. Now, you can use this directly, but what we're going to do is type this longer command, which essentially reruns what we've just run, but then pipes the output into Docker login with the username AWS. And essentially this is going to log into our repository within ECR. Now, there is a placeholder that we need to fix. So just move the cursor back to this period and then delete the account ID _replace me. So we need to remove that entire placeholder. And then if we just go back to any other tab that's open to the AWS console, click on this drop down, and then I'll need you to click here to copy your account ID into your clipboard, move back to this screen and paste that in. And that will mean that you're logging into your particular instance of ECR, and that's important. So once you've done that, go ahead and press enter. And that's going to authenticate you against ECR and then use Docker login to log you in. And now you have access to any Docker images within your instance of ECR. You can safely ignore this warning. This is essentially saying that it's placing a password unencrypted within this file. But that's fine because we're going to delete this instance once we've finished using it. Okay, so the next step is we're going to use the Docker pull command to download the Docker image that we just created using CodeBuild. To do that though, we need to get the URI for our Docker image. Now, that's the unique identifier that we can use with the Docker pull command. So move back to the tab that you have open to the ECR console, and go ahead and click on repositories, and then click on the CodePipeline repository, and then click here to copy down the URI to this Docker image. Then go back to the EC2 tab and run docker space pull, and then paste in the contents of your clipboard and press enter. And that's going to download the Docker image that you just created with CodeBuild. Now that that's downloaded, we can run a docker space images just to display a list of images that we've got on this EC2 instance. And this CodePipeline image is the one that you created with CodeBuild. What I want you to do is to copy the image ID into your clipboard. And then we're going to go ahead and run this Docker image. We'll do so with docker space run space -p space 80:80, and this means port 80 on the container will map to port 80 on the host, which is the EC2 instance, and then a space, and then paste in the image ID that you've just copied onto your clipboard. Once you've done that, press enter, and that will run the Docker container that we've just created with CodeBuild. What we need to do now is to go back to the EC2 console, click on Instances, select Public EC2, and I want you to go ahead and copy down the public IP version 4 address of this EC2 instance. Once you've done that, I want you to open it in a new tab, but make sure that you open it with HTTP and not HTTPS, because we only have HTTP configured on this instance and on our Docker container. So go ahead and do that, and what you should see is this website. If it fits, iSits, in a container, and this means that our CodeBuild process was successful in creating our Docker container using the code, so the images, the index.html file, and the Docker file contained within our CodeCommit repository. And that's good, everything's working as it should be. Now at this point we've reached the end of stage 2 of this demo series. And we don't need this EC2 instance any longer, so you can close down any tabs that you have open to the EC2 console, including the tab connected to the EC2 instance. What you can do is go back to CloudFormation, make sure that you have the Docker stack selected, and then click on Delete and confirm that deletion. And that will just tidy up the EC2 instance because we don't need it anymore. Now at this point, you've reached the end of this stage, you've done everything that you need to. You've configured ECR, you've created a build project within CodeBuild, and you've used a build spec.yaml file to take everything in the CodeCommit repository and use it to build a Docker image which you've stored in ECR. And that's everything that we need to do in stage 2 of this demo series. Now next we're going to extend this by using CodePipeline and automate the process, so every time anything is committed to the CodeCommit repository, CodeBuild runs the project and builds a new version of the Docker image. So we're starting to automate our build and deployment pipeline. We've not yet got a deployment stage, and we're not going to be adding that in the next stage of this demo. Instead, we're going to set up the first part of the pipeline and add deployment in the last stage of this demo series. So next we're only configuring CodePipeline. Welcome back to stage 3 of this advanced demo series. In this stage you're going to create a code pipeline which will include source and build stages. Now the idea is that instead of having to manually run the code build stage, you're going to configure CodePipeline so that whenever anything is committed to the CodeCommit repository, the build step is automatically executed and a new version of the Docker image is created. So let's go ahead and get started, and to do that we need to move to the CodePipeline console. So in the search box at the top, type CodePipeline, and let's open that in a brand new tab and move to that tab. Now we're going to create a pipeline, so go ahead and click Create Pipeline, and for the pipeline name, put cat pipeline. Now, as with most AWS services, if we need to provide permissions for CodePipeline to interact with anything else, then that's done via a service role. So in this case, we're going to allow CodePipeline to create a new service role, and we're going to use the default name. So AWS CodePipeline service role -US-East-1 cat pipeline. Now, in addition to this, I just want to draw your attention to this advanced settings area, so expand that, and in here we can set where the artifact store is located. And this is where the output of any of the stages within a code pipeline can be stored if they're configured to do that, and where the inputs for any stage can be loaded from. And this is how you tie individual stages together within a code pipeline. Now, we're going to leave this as the default location, which will create a default S3 bucket in this account. We could also choose a custom location, but we're going to use the default, and we won't be changing the encryption key settings. We'll be using the default AWS managed key. Okay, so let's go ahead and move on. And first we need to define the source stage, so the source provider. So we're going to click in the drop down and select AWS CodeCommit. We'll need to select the CodeCommit repository that we've been using to this point, so click in the name box and select cat pipeline-CodeCommit and whatever random numbers or letters you defined on the end. So go ahead and click your repository. Select main under branch name. Now, in terms of the change detection options, you can have CodePipeline periodically check the repository for any changes, but we're not going to use that. Or you can use CloudWatch events, and this means that whenever any events happen to the CodeCommit repository, this will automatically be detected in an event-driven way by CodePipeline. And that's what we want. So we're going to pick Amazon CloudWatch events, and for output format, we're just going to use the CodePipeline default. This means that the default zip format will be used for artifacts in the pipeline, and that's fine, that's all we need. So go ahead and move on to the next step, which is the build stage. For build provider, we're going to pick CodeBuild. We can also use Jenkins, which is a third-party build product. I'll be talking about that elsewhere in the course, but for now, we can go ahead and use CodeBuild. You need to pick the region that the build project is located in. In our case, it's US East 1, so we can leave this selected. And then for project name, click in this box and pick cat pipeline-build. Now, this build project already exists, and so we don't need to provide any other environment variables. For build type, we're going to be using a single build because this is a simple project. For more complex builds, you might use a batch build, but for this demo lesson, we're going to go ahead and use single build. So until this point, all we're doing is including the previously configured elements, so the CodeCommit repository and the CodeBuild project, which we've previously created and configured. Now let's go ahead and move on to the next stage, which is the deploy stage, and we're not actually going to configure this in this stage of the demo series. That's coming up next. So we're going to skip the deploy stage. So click skip deploy stage. You need to confirm that process, so click on skip. We're given the opportunity to review everything we've configured, everything looks good, scroll down to the bottom and then create the pipeline. Now the pipeline is going to perform an initial execution, and so if you leave this screen displayed, what you'll see is the source stage will run and it should succeed, and then it will move on to the build stage, and the build stage will execute based on what's inside the CodeCommit repository. And you should find that this build stage runs without any problems. What I'm going to do is I'm going to go ahead and pause the video until my build stage either succeeds or fails. You should do the same, and we can continue once the status changes to succeeded or failed. Now in my case, the build stage was successful. Now what I want to draw your attention to is the artifact bucket in S3. So click in this search box at the top and type S3 and then open a new tab to the S3 console. Move to that tab and open the bucket which begins with CodePipeline-US-East-1. Inside that bucket, there should be a folder called cat pipeline. Go in there. And inside there, Currently, there will be a source arty folder. So inside there are the source artifacts, and this is just a zip file. Now we don't need to worry about that for now. We're just going to go back up one level by clicking on CodePipeline. So this is where the artifacts will be stored for our code pipeline. And currently we're not generating any as part of the build step. Now we do need to generate an artifact so that we can later use CodePipeline with CodeDeploy. So the next step is we're going to update our buildspec.yaml file, and we're going to add some additional lines, including a directive to generate some artifacts. So I'm going to move across to my code editor. So this is the existing buildspec.yaml file. This is the one that we've already got on our local copy of the repository. What I want you to do is to refer to the updated code snippet. So there's an updated buildspec.yaml file contained within the stage 3 instructions. So I want you to copy all of that into your clipboard and then select all of the existing version, delete it, and paste in the new version. Now, as before, I want to make sure that there are no tabs in this file. So I'm going to select all of this. In my case, with this editor, I can click on Editor and convert tabs to spaces. Now, depending on what code editor you use, this might be in a different location, but you need to make sure that there are no tabs in this document, because strictly speaking, you can't have tabs in a YAML document. So we need to make sure that they're all spaces. So this updated buildspec.yaml file does a number of things. Firstly, it gets the commit hash from CodeCommit. So whenever you commit anything into a CodeCommit repository or most source control systems, you get a commit hash or a commit ID. And what we're doing on this line is getting that and putting it into a variable called commit_hash. In addition to that, we're also setting a variable called image tag, and we're doing that within prebuild. We're still authenticating against ECR using AWS ECR get login password as well as Docker login in the pre-build section. In the build section, we're still outputting these diagnostic messages, and we're still running a Docker build against the current directory. So that's using the Docker file to generate a Docker image, and then we're tagging that Docker image. Now, where the bulk of the changes are in the post-build section. So what we're doing now in the post-build section is we're running two different Docker pushes. One which is pushing with the latest tag, and one which is pushing with the image tag. Now, the image tag will include the commit hash, and that means that every time we push a new Docker image into our repository, we get a uniquely identified Docker image based on the commit ID that we make to the CodeCommit repository. In addition, we're updating the latest tag to always represent the latest Docker image. So basically what that means is we'll have a history of any Docker images, and they'll be mapped back to specific commits, and then we'll always have the latest tag. Now, in addition, what we're doing is we're creating a file called imagedefinitions.json, and this is what's used by CodeDeploy when we're deploying through to ECS. So this is an ECS specific implementation detail. So we're generating imagedefinitions.json, and then we're defining this as an artifact. So this means that this is going to be stored within the artifact bucket, and it's going to be available to the next step of the code pipeline when we create it, which is going to be the deploy stage. So now that we've got that updated buildspec.yaml, I want you to go ahead and save that into your local copy of this repository. So save that file. Then I want you to go back to the AWS console and go back to the code pipeline screen. I want you to click on pipelines and then click on cat pipeline. And you can see the previous step is succeeded. So this is currently not running. So the source stage is not running and the build stage is not running. What I want to demonstrate now is what happens when we do a commit to the repository. Now, we've currently updated the buildspec.yaml file. So this is a great thing that we can commit to the repository and see exactly what happens. So go ahead and move to your terminal. I'm going to clear the screen to make it easier to see, and then I'm going to rerun the same three commands that we're used to. So git space add space hyphen capital A and then a period. And this will add all of the files in this folder, including the updated buildspec.yaml. Next, git space commit space -m and then speech marks to add a message. And then in there, I'm going to put updated space buildspec.yaml. And that means that we just know what we've updated. And then I'm going to use a git space push to push that commit into the AWS CodeCommit remote repository. Now, because we've set up this code pipeline, what's going to happen when we push this commit is the CodeCommit repository is going to get this updated commit and it's going to generate an event. That event is going to be seen by CloudWatch events, and that's going to be used to initiate a run of our code pipeline. So let's do this push and move back to the AWS console. Now, what we should see when we're back at the console is that once this commit has occurred, once this event has been generated, we should see that this pipeline begins an execution. So I'm going to refresh, and we can see that the source stage has succeeded and the build stage is currently in progress. And that means that this has worked. We've run a commit to the repository. This is the commit ID, and the comment is updated buildspec.yaml, which is what we've just done. So we've generated an event using CloudWatch events. That's caused this pipeline to execute. The source stage has succeeded, and now the build stage is in progress. And this is generating a brand new Docker image with the updated content of the repository. So this is now a completely automated process. Whenever we commit anything to our CodeCommit repository, this pipeline is going to execute and it's going to generate us an updated Docker image. Now we just need to give this a few minutes to run. Once it does complete, I want to show you exactly what's been produced. So we're going to have a look in ECR as well as have a look in the artifacts bucket, because both of these are important to understand. Hopefully though, in my case, it's going to be successful, and it's succeeded with the build. So now I want to show you two things. So first, we're going to go back to ECR, and we're going to do a refresh of the cat pipeline repository. Now, instead of just the image tag of latest, now we have an image tag of commit ID, latest. So because we've only got one updated Docker image, this is tagged both with latest and with the commit ID. If we reran the process that we've just run, we get a new Docker image. That one would be tagged latest, and this one would only have the commit ID. So we're maintaining the history of any images that we're creating by using the commit hash or the commit ID. So that means that we can always map back these Docker images to the commit that was used to generate them. And that's important, especially in the real world. Now, if we go to the S3 console, you should still have a tab open to it. And if we refresh, now in addition to the source artifacts, we now have another folder which represents the build artifacts. If I go inside there, we can see a single file. So if I click on it, click on download, that will download it to your local machine. If I go to my downloads folder and then extract that file, what we can see inside it is image definitions.json. And this is the file that's been generated by CodeBuild. It's set as an artifact, it's stored in the artifacts bucket, and it's going to be used during the next stage when we use a deploy stage to deploy through to ECS. So I'm just going to go ahead and open this file, and this is the contents of that file. It essentially specifies the cat pipeline name as well as an image URI, and this image URI points to the Docker image that we've just generated, and so this can be used during a deploy stage to deploy this out to ECS, and we're going to be using this during the next stage of this demo series. Now at this point, that's everything that you need to do in stage 3 of this demo series. So in stage 3, you've successfully set up the first few stages of a code pipeline, the source stage and the build stage. And you've made it so that now we have a build operation that's performed whenever anything is committed into our CodeCommit repository. And of course, the output of that is a brand new version of the Docker image together with the image definitions file, which I've just demonstrated. Now in the next and final stage of this demo series, we're going to bring everything together by adding a deploy stage, which will be deploying our Docker image out to ECS. Welcome back to stage 4 of this mini project, where you're going to add a deploy step to your code pipeline. The deploy step is going to take the Docker images that you create during the code build stage of the pipeline and deploy them out to ECS. We're going to have ECS running in Fargate mode with a load balancer sitting in front, presenting an endpoint to our application. And we're going to make it so the code pipeline will run a deployment, so updating the containers used by ECS Fargate whenever a commit is made to the CodeCommit repository. And it's going to handle that deployment to ensure that service isn't interrupted. Now there are a few things that we need to do before we start on the actual deploy stage of our code pipeline. First, we need to configure a load balancer. So to do that, click in the services box at the top and type EC2 and then open a new tab to the EC2 console. Once you're there, scroll down and on the list on the left, click on load balancers. We need to create a load balancer, so do that. It's going to be an application load balancer, so click on create next to application load balancer. For load balancer name, it's going to be CodePipeline, and it's going to be an internet facing load balancer using IP version 4. Now for network mapping, make sure that the default VPC is selected. You will need to have a correctly configured default VPC in order for this to work, and if you are using a dedicated training account, this should all be configured. So make sure that you've got the default VPC selected, and then go ahead and select all of the availability zones in this region. So 1A, 1B, 1C, 1D, 1E and 1F. And because we're using the default VPC, there should only be one subnet in each of those availability zones, so that's good. Now under security groups, go ahead and click on create a new security group, and this is going to open a new tab. For the name and the description, we're going to use CodePipeline-SG. Make sure the default VPC is selected under basic details. We're going to add an inbound rule, so click on add rule. Under type, click in the drop down and pick HTTP. And then for the source, custom and 0.0.0.0.0/0. Once you've set that, go ahead and create the security group. And then you can close down the new tab. Go back to load balancers, click on the refresh icon, and then select that security group, so CodePipeline-SG, and then go ahead and delete this default security group. Now scroll down and under listeners and routing, go ahead and click on create target group, and again that will open a new tab. Now this target group is going to be pointing at containers running inside ECS Fargate, and so it needs to have a target type of IP addresses. So select that option. For target group name, call it CodePipeline A-TG. Make sure that you have HTTP and port 80 selected for the protocol and port, that the IP address type is IPv4. Make sure the default VPC is selected and HTTP1. Then you can scroll down to the bottom, click on Next. We won't be registering any targets at the moment, so this can all be left blank. Just go ahead and create the target group. Once that's done, you can close down this tab, hit the refresh icon next to the listener, and then select the target group that you've just created. So that's going to make sure that anything hitting the load balancer on port 80 is going to be directed towards this target group, and that's what we want. That's everything we need, so scroll down to the bottom and create the load balancer. Now this will take a few minutes to create, but we can continue to the next part of this stage of the demo while it's creating. So click on View Load Balancer just to close down that dialog. Then we need to move to the ECS console. So click in the search box at the top and type ECS and open that in a new tab. Now, depending on when you do this mini project, you might be prompted about UI changes. If you do see a toggle, make sure you have it selected to use the new user interface. If you don't see the toggle, then that means you're using the new interface by default and you don't need to worry about it. So if you do see any dialogues, make sure you select the new user interface, close down those dialogues, then click on clusters and we're going to create an ECS cluster. For cluster name, call it all the cat apps, and then make sure networking is expanded. Select the default VPC. It should be the one that's selected by default, but just make sure that it's selected if you have multiple. All of the subnets inside the default VPC should be selected by default, so leave those as is. Scroll down. If it's not already, expand infrastructure. By default, AWS Fargate is selected, and we need that option, so leave it as is. Everything else is good, so go ahead and click on Create. And now we need to create a task and container definition. Now, the way that deploys happen with ECS using CodeDeploy is that we first need to perform an installation manually. So we're going to create a task and container definition manually, and then we're going to create a service and spin that up ourselves. Once we've done that, we can then use CodeDeploy to update this service whenever we make a new Docker image. Now go ahead and pause the video, wait for your cluster to finish creating, and then you're good to continue. Once your cluster's finished, go ahead and click on Task Definitions, then click on Create New Task Definition. Under Task Definition Family, put CodePipeline Demo, and then under Container 1 in Name, use CodePipeline. For the image URI, we need to move back to the ECR console, and then click Copy URI next to the latest image, then move back to ECS and paste that in to the image URI box. Everything else can be left as is. We'll scroll down and click Next. Make sure Linux/x86-64 is selected under the operating system architecture. Change CPU to 0.5 vCPU, and then memory you can change to 1 GB. Then scroll down and set the task role and the task execution role both to ECS task execution role. Everything else looks good. We can scroll down and click Next. Review that and then click on Create. Now we're going to go ahead and deploy this task definition using a service, and we're going to do it manually first and then use this service later on with CodeDeploy. Now before we do that, you can click on the JSON tab and actually look at exactly what the container and task definition look like, and you'll be able to see under this image section we've got the URI for the image that we created earlier. And again, when we use CodeDeploy to deploy this, this is going to be updated with a new image. Now to deploy this manually to start with, click on the Deploy drop-down and then Create Service. Under the existing cluster drop-down, click and select all the cat apps. Under Compute Configuration, we're going to use Launch Type, so click Launch Type and make sure Fargate is selected in the Launch Type drop-down. Then scroll down, and under Service Name, use CodePipeline Service. Set the desired tasks to 2 so we have some high availability. And then under Deployment Options, expand and just make sure Rolling Update is selected. In my case, it's the only available option. Scroll down, expand Networking. Make sure the default VPC is selected. All of the subnets in that VPC should be selected by default. Go ahead and click in the Security Group Name drop-down and select CodePipeline SG. Leave the default security group present as well. Make sure you enable public IP, so make sure that's turned on. Then expand load balancing and select Application Load Balancer. Select to use an existing load balancer and choose the load balancer that you created. Under Choose Container to Load Balance, make sure it says CodePipeline 80:80. Under Listener, use an existing listener and select 80:HTTP, which is the listener you created earlier. Under Target Group, use an existing target group, click the drop down and select CodePipeline A-TG. Then expand Service Auto Scaling and make sure this option is not checked. Everything else looks good. Scroll down to the bottom and click on Create. And you'll see that it's currently deploying as part of this service 2 tasks. What we need to do is make sure they both say running under last status. So click on refresh. Now if you don't see this, just go ahead and pause the video, wait until both of these say running, and then you're good to continue. There we go, we've got running, and that means everything's working as it should. Now we need to test that our container application is currently working without any issues. To do that, move back to the tab that you've probably still got open to the EC2 console. If you don't, just type EC2 in the search box at the top and open that in a new tab. Scroll down on the left and go to Load Balancers. Select the CodePipeline Load Balancer. Next to DNS name, copy that into your clipboard and then open that in a new tab. And again, make sure that it's using HTTP, not HTTPS. And what you should see is our application, and this is now running in a highly available way. It has 2 containers, each in different availability zones that are part of our target group that our load balancer is currently set to use. So our requests are currently using a highly available containerized application. Okay, so now what we need to do is add a deploy stage to our code pipeline so that we can deploy whenever anything new is committed to the CodeCommit repository. So to do that, we need to move back to the CodePipeline console. If you still have this open, move to that tab. If not, type CodePipeline into this box at the top and open it in a new tab. Then click on Pipelines. Click on CodePipeline to move into the pipeline that we're working with, and click on Edit because we're going to add a new stage to this pipeline. We're going to add a stage, so click the button to add stage after build, and we're going to call this stage Deploy. So enter that and click on Add Stage. Then inside the Deploy stage, we're going to add an action group. For action name, put Deploy. For action provider, scroll down under Deploy, and we're looking for Amazon ECS. So select that, and we'll see some ECS specific deployment configuration. So for region, make sure it says US East Northern Virginia. For input artifacts, click in the drop down and select build artifact. So this is going to use the image definitions.json, which remember is an artifact of the build stage. So we're going to use the image definitions.json file in order to deploy our Docker image through to ECS. So select build artifact. For cluster name, go ahead and select the ECS cluster you just created, so all the cat apps. For service name, pick CodePipeline service, which is the service you just created. Now under image definitions file, add image definitions.json. So this is the name of the artifact that's output as part of the build stage. Now we can leave everything else as default and then click on Done. And this has added a deploy stage to our code pipeline. So this means that whenever we commit anything to our CodeCommit repository, it's going to run a build, generate a Docker image, store that Docker image on ECR, and then it's going to execute a deploy stage which will deploy that Docker image out to the service that we've configured within ECS. And all of that will happen automatically whenever we commit anything to our CodeCommit repository. So we just need to go ahead and save this, confirm that by clicking on Save Again. So this is not going to execute, so what you should see is the status at the end of the previous execution. So you'll see succeeded for source, succeeded for build, but didn't run for deploy. And that's logical because we haven't run this code pipeline while this extra step has been present. Now to test this, what I want you to do is to open up the index.html file that's in your local copy of the repository. This is what it looks like. So this is the container of cats index.html. So it says, if it fits, I sits in a container in a container. What we're going to do is add hyphen space and then with space automation. So we're editing this index.html file so that when we save it and commit it, we can see whether this has been updated when we refresh the page that's open to our containerized application. So this should be a fully automated process. Once this is saved and committed, our application should be updated. So let's save this file, move to our terminal, clear the screen to make it easier to see, and then we're going to do a git space add space -A and then a dot to signify the current folder. So we're adding the updated index.html. We're going to commit that, so git space commit space -m for a message and then test pipeline. So commit that. And lastly, we'll do a git push. Now, when we do a git push, what will happen is the CodeCommit repository will get these updates. An event will be generated. That event will cause an execution of our code pipeline. A build will occur. That build will generate two things. One, the updated Docker image, and two, the image definitions.json. Image definitions.json is an artifact of the build stage. The deploy stage will run and update our service based on that new output. So I'm going to go ahead and push that up to CodeCommit. And there we go. That's now been pushed to our remote repository. So let's move back to the AWS console. We can see source is currently in progress. That means that it's received the commit that we've just pushed. That then moves to the build stage. So we're now building a new version of our Docker image based on the changes that we made to our CodeCommit repository. So I'm just going to refresh. It's still in progress. So we just need to wait a few moments. Just keep refreshing until you see a different status. If you do want to get any details, you can right-click on Details and open that in a new tab to go to the CodeBuild console. And you'll see the logs. We can see it's currently in progress officially, but it does look as though it's finished. That's good. So go back to CodePipeline and hit refresh. So the build stage has completed, and now the deploy stage is in progress. So if we click on Details to open that in a new tab, this will show us the details of this deployment. We'll need to click on Deployments and Events. You can see we have a rollout state of in progress, so this is now updating the image that's used for our containers. You can see that we've started 2 additional tasks, so those are the tasks using the new Docker image, and those tasks have been registered in the target group. So we'll be able to monitor the status of the deployment. Now I'm going to skip ahead and chop out any of the boring bits while I'm waiting for this to work. You should pause your video and wait for your status to complete, and then you're good to continue. We'll see the deploy stage has now moved into a succeeded state, and that's our first deployment performed by CodePipeline in an automated way. If we go back to the tab that we have open to the Container of Cats application and hit refresh, we can see that it's now our new version of the application with our text of with automation. So we've now configured a fully automated code pipeline which creates a Docker image and deploys that out to ECS. And that's the end of this stage of this demo series. It's been a relatively simple example of a deployment pipeline, but you've created an architecture which you can extend and use for real-world situations. So this is the architecture that you've implemented during the 4 stages of this demo series, and this is the type of deployment pipeline that you'd use in the real world. Now this is everything that you need to do in this stage of the demo series. All that remains in the next and final stage is for us to clear up the account and return it into the same state as it was at the start of this demo series. Welcome back to stage 5 of this demo series, and the only thing left to do is to clean up the account and return it to the same state as it was when we started this demo series. So to do that, let's go back to clusters, go inside the cluster, select the cat pipeline service and then delete it. Check force delete service, and then you'll need to confirm that by typing delete and clicking delete. Once you've deleted that, go to tasks. If there are any tasks in that list, select them, click on stop, and then stop those tasks. Then go to task definitions, go inside the definition, select all the different versions, click on action, deregister, and confirm. Click on task definitions, make sure that's empty. Go to clusters, Select the All the Cats cluster and delete the cluster. And again, you'll need to confirm it and click on Delete to remove the cluster. Next, go back to the EC2 console, click on Load Balancers, select the CodePipeline load balancer, click on Actions and delete it, and then click on Delete. Once that's finished, go to Target Groups and select the target group you created, click on Actions and delete the target group, and you'll need to confirm that process. Then go to the CodePipeline console, click on Pipelines, select CodePipeline and delete the pipeline. Type delete into the box and then click on Delete. Go to Deploy and click on Deployments. Check that's empty. Click on Applications, make sure that's empty. If there is anything there, go ahead and delete it. Click on Build, go to Build Projects, select CodePipeline Build, delete the build project. You'll need to confirm that, so go ahead and do that. Go to Source, click on Repositories, select the repository you created, so CodePipeline-CodeCommit, and then some random, so select it, click on Delete Repository, and delete it, confirm that process. Then move to the S3 console, we need to delete the artifacts bucket, so select the CodePipeline bucket, empty, you'll need to enter permanent delete and click on empty, exit. With it still selected, go ahead and click on delete. You'll need to put the full name of the bucket in there and click on delete bucket. Once that's done, type I am in the search box at the top and move to the I am console. Click on roles, scroll down, find the CodeBuild-CodePipeline-build-service-role. Select it and then click on delete and then enter the name to confirm that deletion and click on delete. Then go back to the EC2 console, go to Security Groups, select CodePipeline-SG, click on Actions, delete Security Groups and confirm that deletion. Then you need to move back to the Elastic Container Registry, click on Repositories, select CodePipeline, click Delete, and then confirm that deletion. And that's everything back in the same state as it was at the start of this demo series. So that's the end of this CodePipeline advanced demo. You've implemented this architecture, and everything you've learned and experienced in this advanced demo series can be used both in the real world and within AWS exams. So I hope this has been an enjoyable demo where you've got the opportunity to increase your practical skills in these areas. With that being said though, that is everything that you need to do in this advanced demo series. I hope you've enjoyed it, but at this point go ahead, complete this video, and when you're ready, I'll look forward to you joining me in another exciting advanced demo.